Hello everyone. Today I'm going to tell you about remote method invocation. It is again inter-process communication. Let's start with this now. What is remote method invocation? See, remote method invocation, it is an application programming interface which allows an object to invoke a method on an object. Basically, RMI is the one which works on the object. We also have one more inter-process communication which I will be telling in one of the other video of mine. There it is remote procedure call. I will tell you that time the difference between this remote method invocation and RPC. So they are just the same thing, but both working in a different way. So this remote method invocation allows an object to invoke a method on an object that exists in another address space, which could be on the same machine or on the remote machine. So object which is running will be a client and another one will be a server. So it creates a public remote server object that enables the client and server-side communications through simple method calls on the server object. So now let's see how the RMI works so that we will be able to understand it better. The communication between the client and server is handled by using two intermediate objects, that is the stub object and the skeleton object. So basically, remote method invocation is the one which creates two different objects at two places which wants to communicate, which of them want to communicate with each other. For example, if we have a client and server, at client side one object is created and at the server side another object is created. They are specifically named. One, the client side is called as a stub object, and the one which is on the server side is called as a skeleton object. Let's move forward now. So this is a small diagram which I have put up here. How actually the RMI works. The working is I'm going to explain it further. Just look at the diagram how it works. See, as I told you, there will be a client and a server, and each of them have their own objects created at their end. So first thing what happens is basically a client has to make a request to the server. Further, I have explained with an example of addition of the numbers. There we will be able to better understand how stub and skeleton objects will be created, and they help in the communication between the two processes, you can say. So first thing is register server object. So the first thing is done here. At the server side there is a registry which is a naming registry. So this naming registry is the one which contains the server object registration. So once this is done, client will start doing the lookup for the server object. Then it will return the server stub. Once it returns the server stub object, there starts a communication. This we can see it better here now. Stub object, what do you mean by that? Stub object on the client machine builds an information block and sends this information to the server. So the block consists of what? The identifier, method name, and the parameters. So basically, stub object is nothing but a client-side object. Okay, it has some of the things packed in it, that is the identifier, method name, and the parameters. Now, when the caller invokes method on the stub object, it does the following tasks. It initiates a connection with remote virtual machine. It writes and transmits the parameters to the remote virtual machine. It waits for the results. It reads the return value or exception, and finally returns the value to the caller. So this is all about the stub object. Let's see what does a skeleton object do. Skeleton object passes the request from the stub object to the remote object. When the skeleton receives the incoming request, it does first thing is reads the parameters, invokes the method, and finally writes it and transmits it. So there comes a word called as marshals. Marshals means it packs everything. Whatever the data has to be returned to the caller, that is to the client, it packs it and sends it to the caller. This is called as marshalling. At the same time, the opposite meaning for marshalling is unmarshalling, where the data which is packed is unpacked and read and written. So this is about the skeleton object which is on the server side. Now let's start with the implementation of this RMI. First thing is defining the interface for the RMI. We have to define an interface. Remote method invocation has an object creation, so all object-oriented programming languages are used for the implementation of the RMI. Implementing the remote interface. Then we create the stub and skeleton objects. We start the RMI registry, then we create and execute the server application, and then finally the client application. Let us take this example. What is done here is, actually we have two things going to be represented in this RMI explanation what I'm doing now. First problem what I've taken is addition of two numbers, which I'm doing it in the same local host system by opening two different tabs, one for the client and one for the server. Next is between the two systems which are connected in the local area network. So the same application of adding two numbers, I've done it in two ways, one at the local host, other at the connected in the systems which are connected in the network. Let's begin now. Client application needs only two files, one is remote interface and the client application. In RMI application, both client and server interact with the remote interface. So this is what is the example is going to do. First we have the client object, then we have the server adder. So server will do this addition and returns the result to the client. And how does it do? It has to implement a interface, that is nothing but a adder interface. This is the reference for this diagram which I got it from. So before we start up with all the RMI, I would like to tell you, like, I'm going to implement this RMI in a Java environment. So for that, first step to do is we have to install the JDK. Let's begin with the installation of JDK. So first we have to go to the given link here. Then you accept the license. Then in the download menu we have to click the download link. And if you are using Windows, go for the Windows version, and whatever you have OS that you can you see there, and to take that particular version. Then run the JDK installer. So how do we run it? Start it. I have JDK 8, so I have given the explanation on 8. Then follow the instructions that are provided. Then JDK includes various packages and all. So the installer will integrate all this into one JDK installation directory. Finally, once it is installed, the important part of installation is the path environment variable. To set the path environment variable in Microsoft Windows, which I have used, is we have to go to the control panel, system advanced and environment variables. Therein we have to put the bin folder path in the system variables. This is the thing about installation. But let me tell you, why do we need these path variables? Without setting the path environment variable, every time you compile or run the Java program, you have to provide the complete path of Java C. See, whenever you have a hello.java program, you have to give this path every time. So instead of that, if you set that particular path environment variable, you need not have to do this again and again. Once you set the path environment variable, you can compile and run the Java programs without giving complete Java C path every time. This also removes the dependency of saving .java files into bin directory for compilation. Now let's begin with the RMI implementation in Java environment. First thing is we have to create the remote interface. For creating the remote interface, extend the remote interface and declare the remote exception with all methods of remote interface. Here we are creating a remote interface that extends the remote interface. There is only one method named add. So I'm going to explain RMI with a very simple example of addition of two numbers. So I'm using that particular method add, and it declares the remote exception. Here is the code. I'll just show you the code. So this is for the solution 1. I have already explained you earlier, there are two problem statements I have given, one for the local host and another for the systems running in the network. So this is for the adder interface, which is in the local host environment. This is the application in the local host where we have the adder interface. Okay. So there is a small comment written here. It says that why do we have to import java.rmi? The interfaces and classes that are responsible for specifying the remote behavior of the RMI system are defined in java.rmi package hierarchy. What we are doing here in this code is it is extending remote. Again, it is in this header file. We are calling public, we are writing public int add int xy, which I am going to implement in the class later. It throws remote exception. Now let's see how do we do the same code when we are connecting two systems in a network. Okay, see, again there also we are writing the same code, but with I have done with it with a different name, addition interface, just to make a difference between the two. Okay, so let's see. I hope you have got what I am doing here, solution 1 and solution 2. Solution 1 here, everywhere it means the code which is written for the local host application, and solution 2 will always tell us the code about the two system applications which are running in the network. Okay. Next we see the providing the implementation of the remote interface. Now we have to provide the implementation of remote interface. For providing the implementation of remote interface, we need to extend the unicast remote object class. In this, we extend the unicast remote object class and we define a constructor. What does this mean? So I have written just a prototype here. This is the prototype. It is used for exporting a remote object with JRMP. What is JRMP? It is a Java Remote Method Protocol, and it obtains a stub that communicates to the remote object. So when we create a stub object, some protocol has to be there. It has to take that object so that it can communicate with the server. For that it is used. So the word itself says that exporting a remote object. Okay. So what I have written here, some of the methods that are used in this unicast is, one is the clone. It throws clone not supported exception, returns the clone of the remote object that is distinct from the original. It returns the new remote object. It throws clone not supported exception if clone failed due to a remote exception. It overrides clone in the class object. Then you have export object. This is the prototype for that. What does it do? It exports the remote object to make it available to receiving incoming calls. So this object parameter is the remote object to be exported. So this is the one which is to be exported. It throws remote exception if export fails. So let's see the code, what we have done in the code. We have extended unicast remote object here, and what is this adder remote? It is a class name. It is implementing the adder. Adder is what? The interface that I have defined already in the code earlier. It throws remote exception. Here it is a constructor. So here I'm going to add and return the result. Okay, so this is the class which is the adder class communicating between the client and the server. It actually exports the object of the stub, does the addition and exports the object of the, gives it to the skeleton. There it does addition and gives it back to stub object. Next important step is creating the skeleton and stub objects. For that we make use of RMIC compiler. What is the syntax for that? It is here. We write RMIC adder remote. This is how I had written it in my program. Then we do is we start the registry service. Naming registry is a very important part where we have a few things to understand. This is a remote object registry is a bootstrap naming service that is used by RMI servers on the same host to bind remote object to names. Why do we need this? See, the client has to communicate with server. If the two of the applications are running in two different systems in a given network, or they are on the same system as a local host, if they have to communicate with each other. How do they do? That is done by the stub and skeleton objects. But if they have to communicate, they have to find each other. So there should be some registry where one of them have to register and the other one has to look up for that. For this purpose, we make use of this registry service. So it is a bootstrap naming service that is used by RMI servers on the same host to bind remote objects to names. Clients on local and remote hosts can then look up remote objects and make remote method invocations. The registry is typically used to locate the first remote object on which an application needs to invoke methods. That object is in turn providing application-specific support for finding those objects. Okay, then the methods of java.rmi.registry.locate registry class are used to get a registry operating on the local host or local host and port. Now we start the registry service by using RMI registry tool. We have to specify the port number here. If we don't do that, it takes a default port number. Now the question is what port number we have to choose. We can choose between any of the range from 1 to 65535 except some of the specified ports that are used in the network. This is a table of some of the ports that are already in use in the world now. Apart from all these, maybe I am covering most of them. If there are any other, then we have to leave those also and consider the one which are not being already used in the networks. So in our example, we are running client and server on the same machine first time in the first solution where we are using 5000 port number. Next, in different machines, we are using the port number 1091. This is the syntax that is used. Here we give the port number. It creates and starts the remote object registry, the specified port on the current host. If port is omitted, the registry is started on port 1099. This is a default port number. See, for solution 1 it is 5000, then for solution 2 it is 1091. Now we have to create and run this server application. Now RMI services need to be hosted in a server process. The naming class provides methods to get and store the remote object. The naming class provides 5 methods. So these 5 methods are very important for the naming registry. See, what does the lookup do? It returns the reference of the remote object. What does a bind do? It binds the remote object with a given name. Then we have unbind. It destroys the remote object which is bound with a given name. Then we have rebind. This is what we have used in one first solution. It binds the remote object to the new name. Then finally we have list. It returns array of names of the remote objects bound in the registry. So reference for this is already given here. Now see what is the server code for solution 1. We are implementing in the same system which I have already written here. So for that we have written a code. What we are doing in the code, see. As I mentioned, we are using rebind. So this is the local host. We are taking the name here as demo. Okay. This is the S, which is an object of adder interface, where it is creating with respect to the class adder remote. It binds the remote object to this new name. What does it do? Demo is a new name which is not present in the registry. Demo is a name which is being created now. Once we run this program, it binds the remote object, this yes, with this demo. Okay. With this path, localhost, in the sense we are running in the same system. Okay, Then we see the implementation in different systems. This here we are using locate registry and its methods. Before we do any connectivity in the LAN, we have to first understand that two systems are actually communicating with each other. That is, when we do ping or when we try to communicate with one of the system in which we want to put a client or a server, there we have to have the packet transfer between two systems which want to communicate. For that we have to check it before implementing this. So in this implementation of two different systems, we are using locate registry and its methods. Public final class locate registry which extends object is used. Now let's see what is a locate registry. It is used to obtain a reference to a bootstrap remote object registry on a particular host. Or we create a remote object registry that accepts calls on a specific port. What are some of the methods here? Okay, so static registry, in that we have create registry into port. Similarly, we have create registry with port, socket factory, and some of other things are there. Then we have one more thing, get registry. So this is a default port number. It returns a reference to the remote object registry for a local host on the default registry port of 1099. So this is the one which I got it from the oracle.com. Okay. Server code is actually here in the different machine which I am communicating is like Lenovo 12 is the name of that machine which I have been using here. So some of the header files which are being included, these are the header files. Now let's go to the code. Here I have the code addition. This is the addition class name instead of adder remote what we used in solution 1. This is the port. Okay, we had used 5000 earlier, now we are using here 1091. Then this is exception handling. See, here we have used the locate registry. It is used to obtain a registry to the bootstrap remote object registry on a particular host. Then we print it as registry created. Okay. Then this is exception. Then we write the host name as like this. Then we are using a string named as bind location. Now here we are using bind. Bind means hello is the object which is created for that particular class. For this object and this bind location, we are binding the remote object with the given name. We are using bind in the solution 2. We have used rebind in the solution 1. The difference is rebind will bind to the new object, bind will bind to the existing object. Okay. Then this is about the code. Next, finally, we run the client application. Stub object by lookup method we are getting here of the naming class and invoking the method on this object. Server and client running on same machine. So we are using localhost. This is the client code, very simple code on the same machine what we are running. We are just it lookup, then it returns a reference of the remote object demo which we had used to the same S object for the adder interface. Finally, we return with the same object. We return the addition of two numbers 34 and 4. Test result should be 838. Then we let's see the solution 2 where we are running on a machine with the name Lenovo 11. Here we are running client and there we had seen Lenovo 12 where it was server. So port number, same port, it has to listen to the same port which we had used in the server. Again we are using here is lookup. Connection name. This is the connection location, connect location. This object you get the object here, there you do the lookup. This is about it. Okay. Then here I am giving hello.add 9, 10. here this has to give me a different result. Just when we look up at the output, we will be able to understand how it works. See, this is the solution 1. Outside it is 34,4, so it should be 38. So answer I got is 38. Just I'll show you my answer for this. See, this is 34,8 addition, so it has to give me back the result as 38 in the solution 1. So this is 38 I got. Just look up here, this is for solution 2 when I'm running a client, and see, addition server, if I run here, register already present. So because I had run it one more time before taking the screenshot of this, so it is ready at this port, which is the port I had given here. Then finally I run the client. The answer is 19. Why it is 19? Let's see. It is written in the what we are returning here, 9, 10. So it is 19. Okay, this is the client. Client got the answer. Let's see advantages and disadvantages of this remote method invocation. So remote method invocation can pass full objects. As I told earlier from the beginning, the remote method invocation is an implementation on objects. So it passes objects as arguments and return values, not just predefined data types. Mobile behavior. RMI can move behavior from client to server and server to client. It uses built-in Java security. That is mechanisms that allow your system to be safe when users downloading the implementations. So then we'll see disadvantages. RPC and RMI have the disadvantage that caller and callee both need to be up and running at the time of communication. In addition, they need to know exactly how to refer to each other. So this tight coupling is often experienced as a serious drawback and has led to the message-oriented middleware. So this is the disadvantage. So this I got it from Tenenbaum book. So just to summarize, RMI is a remote method invocation. It is an inter-process communication, we can say, where all the objects are created to communicate with each other. There are two important objects which are created. One is a stub and the skeleton. Stub is on the client side, and server side we have the skeleton object. Both have to communicate with each other. So first thing done is the server will create a registry or register itself in the naming service. Then client will look up for the server object, and then the communication starts happening. This is about remote method invocation. These are some of the references I have used. All the documents or the notes which are given in this document are the references from the references from these given links and book. Thank you.